Lesson 2. All right, what is the explanatory value? You will need to review the section on the way. Okay, so for the explanatory value variable, I got the body length. So the x is equal to the body length, and the y is equal to the head length, because that's a dependent variable or response variable.
So for the first one, you said you got body length?
Yes.
He's got that flipped the other way in the thing. How did we figure that? Because I'm looking at, it says answer the following questions, use the data in the wiki under the data link in the course resources. I'm not saying that. I don't know, it's just me, but I went to the course resources on here and I didn't find it.
Maybe I just switched those because it says the independent variable x and the dependent variable y. And it was talking about, let me pull this up. The dependent variable is the head length in all of the things. So I think I just got that switched. I looked at it and then swapped it on between looking at it and the assignment. So yeah, because the explanatory variable in all the examples in the assignment is the
head length.
Is the head length. And the response variable, which is y, the dependent. Okay, wait a second. It says, yeah, let y be the body length and x be the head length. Okay, yep, so 1 is head length, 2 is body length. I just got those swapped. And then you got the scatter plot, right?
Yeah, I got body length going, what, x and head length on the y, right?
Yes.
So body length going up and down, head length going left to right. And that's what that's what's in the answer key too.
Okay. I had those switched because of my first 2 answers, but it's the same block, so it's still a positive thing. Okay, so I just put that correct one in there. Okay, use the software to compute the value of the y-intercept in the regression line. So this is the predict the value of y for any specific, no. How do you do this one? Do you remember?
This is where you go in, what was it? You go under analyze.
Regression linear, right?
Yes. And then you scroll down once you get that to the coefficients, which is the last box in that part, I believe.
Okay. Just gonna get this out to right, please. And we don't need to do anything, right? We just hit OK, and that comes up.
I believe so.
Okay, and then the coefficients, I got that 0. Okay, and the answer is, what is the y-intercept? And did you get negative 69.369?
Yes.
And then the slope is the 0.326.
7.4. Let's see. Yeah, 7.4.
Oh, there we go. Yeah, I looked at the wrong one. Man, I am struggling today.
Evans, hold on. Had to see where my dog is at. He's laying at the top of the stairs. Strange animal. And then, oh, nice.
So then the thing is just y equals negative 69.369 plus 7.4 times x, right?
Yeah, we just figure out, just plug those numbers into the equation.
Okay, and it says use the software with the line. So here we're going to do the graph with the line, right?
Yeah, you take your scatter plot and then you just draw a line through it, or have the line drawn through it.
Okay, you double click on it, maybe.
Yeah. Yeah.
Okay, and menu. Are you seeing a menu on there anywhere?
I don't remember. I already did this. Let's see. Where'd my scatter plot go? Open it up.
Oh, there we go. Just kidding. It just says elements.
Yeah, just elements. Fill line at total.
Yeah. And just do a linear.
And just
Is yours just a straight line, right?
yeah.
Okay. Says for the observed head length of 51 centimeters, what is the observed body length? So this is just plugging in the numbers, right?
I believe so. This is actually right where I was at when
Okay.
started this. I haven't done this one yet. So just let me go over to this. Reserve length of 51.
Okay.
So looking. Well, if we're just looking at it, it looks like it's 343. Just looking at our data. Yeah.
Okay, so for this one, this is the one where we type in 51 at the bottom of the head length, right?
For number 9, I believe so.
Okay.
For number 8, we just look at the data and scroll up to 51 for the head length, and there's the body length, which is the 8th, whatever.
Okay, so we scroll the head length. Okay, I need to watch the videos on this section for sure because I'm struggling with it. So,
Yeah, so like for number 8, we just look in our data that we already have that they gave us. Look for 51 in the head length, which is on the 8th spot, and just look at what we've got for body length. It's already there.
oh, okay.
Which I was trying to do more than that before, because it just says look in the data to find your answer. Well, that's because it's already there.
That makes it nice. All right.
Yeah. Considering when you type in 51 at the bottom, it doesn't give you, and you do what it tells you, it doesn't give you the observed body length.
No, it doesn't. So it says use the regression line you obtained in number 2 to predict the body length based on the head length of 51.
Which that is where we do, I believe, the whole type the 51 at the bottom.
And we just type it in the bottom of the head length column, right?
Yeah.
And we leave the body length blank, and then we just do. Okay, wait, but I think you do have to. Okay. So scroll down. After the last row, type the value of X, which is the head, not to predict. Value of Y in the cell last row of X. Okay. Okay, you want to save the predicted value, so do the following. Okay, so it says click on save. Okay, save. And then it says, are you reading this or do you want me to read it out loud? Sorry.
I'm reading it too. I'm following along.
Okay, and mark the checkbox for under standardized predicted values. Okay. Click continue, click OK. Okay. Okay, then the only thing that changed is the residual statistics, right? Because then it says use it, okay, to predict the body length based on the head length.
So when you do that, it creates a box next on the other side of the comments box, and that's where we'll get the answer.
Thank you.
That's where the pre_1 column is.
Okay. So this one is 308.03297, right?
That's what I got.
Okay.
And that said, looking at the answer sheet, we could have done this by hand too, because all we're doing is putting the information in and then just solving the equation.
Yeah, in the textbook though, it's like use SPS.
Yeah, the answer is actually appears to be slightly different
Okay.
than what we, because we got 0.03297. 3297. No, and when you figure it out, the way that it looks like that he did it by just plugging the answers in, it got 308 point, where is it? 031.
Okay, yeah.
But the book does continue to say, do it in this. It'll be slightly different.
Yeah. Okay, the number 10, why are the values you obtained in 8 and 9 different? Explain.
Well, it's a good question.
It does, on the plot, 51 is actually above the line.
It's pretty good above the line, right? Let me go back
So
into
the line is on like about close to 300, and 51 is closer to 350 body length wise.
So here's 50. Yeah.
I don't know if that makes sense in the answer or not.
Well, if we're looking, as we're doing this, what we're doing the equation is an estimate.
Okay.
Versus the 343, I believe, is the actual measured body length.
Okay.
Right?
Yes. Yes.
So as we're doing the aligned equation, we're looking at estimating what it's going to be. So it's going to, I mean, the estimation is going to always be off at least a little bit versus what the actual is. And shoot, looking at the data, just taking a glance at it, there are, none of them are exactly the same as what the observed body length is versus what we are estimating it to be.
Yeah. Sounds good. Are we ready to start then?
1 second.
Okay.
All right, let's click on this. Lesson 22. All right, let's start it.
Okay. There.
Okay. All right, you there?
Yeah.
All right, so number 3. Pretty simple.
Okay. Yeah. So for number 3, I got 2.0, of course. Number 4, 1.5.
5, 1.0.
Huh?
Right. 5 is, did you do 5 already?
Yeah, 1.0.
1.0. Yeah, okay. Number 6, make a scatter plot of the math self-efficacy data. Okay, let me go in here and open that up.
Yep, I need to do that too. Hey, puppy.
Of the 3 data shapes introduced in our
Okay, so the score,
so what
it
are we
doesn't
putting
really
in?
matter, right?
Hey, stop. No.
The score versus the score on the y-axis. The x-axis would be,
The confidence rating.
yeah, that's what I did. And I've got, wow.
I know, processing. I feel like I have more of a hamburger one. No, I guess it's a linear pattern still. It's still the hot dog shape. Because it's a definite like net or positive line up. It's just very scattered.
Yeah, I think it's more of the hot dog, yeah, as I'm looking at the 3.
Mm-hmm.
Yeah.
So A on 6 and C on 7.
What can you say about the appropriateness of using simple?
Oh wait, or would it be because the hamburger and the banana one are not appropriate, and it says
Right.
to determine if there's significant linear relationship. So I'm thinking that it might not be accurate.
Well, the answer is not A.
Yeah.
I think it could be reliable. Conduct regression analysis to determine if there is a significant linear relationship. Doesn't really, I mean, if it's a linear pattern, I guess it would be C.
That's what I'm leaning
I can
towards.
see.
Okay, I'm gonna go see. And 8
Yeah.
is how many observations are in the math self-efficiency data. Is that just how many things there are?
That I'm not.
So
Well,
139?
that I'm not sure. How many observations are there in the mass? I Hmm. You could be right.
Okay, so we did the score is on the Y, right? Dependent. And
Scores going up
the,
and down. Confidence is down at the bottom.
yeah.
Right.
Okay. Come on. It says what was that?
I'm thinking that you're right with 139 because they did observe 139 different things or
Yeah,
different scores.
that's what I'm thinking it is.
That's what I'm thinking also. Use be sure to use the confidence data for the explanatory value in the score as a response. So do we have this right or do we have it backwards? Or independent?
Okay, it says be sure you use confidence data for the explanatory value, which
is
we
going
did,
to be
and the score data for the response value.
so then what is the y-intercept?
Okay, I'm getting 18.690 and 12.695.
Okay, yeah.
And it says your answer should be exact.
Yeah. So let me. Hold on. That's right. Okay. Hold on. Okay. Yeah, 18.690 and 12.695. You said.
Yeah.
I got also.
And by exact, I'm wondering if they mean exact, like don't round. 'Cause you know how sometimes it's like round to the third. And this is
Yeah.
no, use the exact. Yeah.
Well, because I also think, see, you can click on the graph and do the fill the line, and it'll give you the numbers also, because it'll put in. You can see the formula, the y equals whatever, but that only goes to two decimals
Yeah.
and not to 3. So that says y equals 18.69 plus 12.69. But there is a little difference there. So, okay. What is the predicted value of y when x equals 4?
Okay, with it 4, it should be 69.46935.
I got 69.47.
Okay, did you do the math in your head or did you do it on the thing?
I did it on a calculator.
Okay, I did it on the thing, so I have a 5. So I have 69.46935. And I'm wondering if that's the same thing as it should be exact. So, and that's why it was.
Probably. So you said 69.46.
935.
35. So just to refresh my memory, how did you do that? We went into, or you went into.
On that one, it says x equals 4. So then we
Yes.
have x being the confidence rating mean. So you scroll down to the very bottom of the confidence rating mean and put 4 and
That's right.
underneath it. And then you go to analyze, regression, linear. But you have to hit save and under standardize and continue. And then remember you exit out and it's the pre_1 thingy.
Yeah. Now my computer's just going. There we go. Now my computer. There we go. Okay. I do that.
Okay, number 12, the confidence data results from students evaluating their confidence after each question on a scale of 1 to 6. What is the maximum predictor value of y for these values of x? So
because there's a positive correlation, we can use the largest x value to find the largest predicted y value. Okay.
and it says use math efficiency or math self-efficiency or whatever through 13.
Yeah. Okay, so
Okay, so that's the confidence rating is what it's talking about with the confidence data, right?
I believe so.
So the confidence is the X. What is the maximum prediction of Y for these values of X? So it would be, you just plug the numbers in for 6 equals X, right? X equals 6. Because if it's the maximum prediction value of Y.
And Y is the score, right?
Yes. So the highest their confidence can be, okay, so the confidence
Is
interval
6.
is 6. That's what I'm thinking.
So are we just looking for the score that would go with that? Fine.
So what I'm doing is I'm changing the 4 to 6 and then doing the analyze regression, save, whatever.
What is the maximum predicted value of Y for these values of X?
So then that comes up as pre_2. So I get Y as 94.859. Does that make sense?
Yeah, no, I see what you did. Because we're just looking for predicted values, so okay.
Yeah.
I think that's right.
Okay, and then 13 is how many explanatory or independent variables are present in the simple linear regression? This one I'm a little confused about.
Well, isn't there only one? Because that's all we're doing?
In the simple linear regression, I'm not sure because the variable X in a simple linear progression, I think you're right, because that's like the line. So there's one X and one Y on the line, right?
That's what I'm thinking.
In a simple linear regression. Okay, 1. Sounds good. 13 and 14, yeah?
That's what I'm thinking.
All right, you ready to submit it?
Yeah. All right, submit.
All right. Woo-woo.
Hey.
Sounds good.
100% for this week on these.
I know, right? It's about time.
No kidding. How much time would you spend on this? Sweet.
Okay, sounds good. I will email the teacher then about, or I'll resubmit the first assignment and get that done. So.
Sounds good.
Okay, sounds good. See you next week then.
All right.
All right, bye.